Welcome back again to solving numerical problems from engineering mechanics by Professor Timoshenko Young from Stanford University in USA and Director J.B. Rao and Professor Sukumar Pati. And now I will be discussing solution to 3.3 problem set 3.1. It is about two gears, and in between there is another gear called a idling gear. And before I proceed, let me show you how a gear looks like. Now look at this diagram. Let me slightly enlarge the picture. I will be able to explain you better. Look at this. This is one gear. There is the axle here. This is another gear here. And the pitch diameter from this point to this point is the pitch diameter for this gear, and the pitch diameter for this gear is from this end to this end. Now the question is, if you try to rotate this gear clockwise in this direction, this gear, if you try to rotate this anti-clockwise, this one will rotate clockwise. If you try to rotate this clockwise, because of this teeth arrangement, if you rotate it clockwise, this will rotate anti-clockwise, right? Now, that's the principle of a gear. So, let's say the radius of this is equal to, the smaller one is equal to r, and the radius of this is equal to 2r. So if this one makes one revolution, it will cover a distance 2 pi times the radius, that is 2r, that is equal to 4 pi r. So in the same time, this has to rotate twice, because the radius is r. To cover a distance of 4r, this has to make 2 revolutions. Means 2 times 2 pi r, that is equal to 4 pi r. That is very interesting part of a gear. If this makes 2 revolutions, this will make 1 revolution, or if this makes 1 revolution, this will make 2 revolutions if the radius of this is r and this is 2r. Now let me straightway go to the statement of the problem. There are 2 gears. I'm clicking this video in a 4K video, but the time duration for 4K video in most of the mobiles is only 5 to 6 minutes, so I have to finish it early. 2 gears having pitch. This is one gear, this is another gear. The pitch of this is 150 mm, and let me come back to the original one, 1.6, so make it 1.4. This is one gear, this is another. The pitch diameter of this is 150 and the pitch diameter of this is 200 mm, and both are joined to each other by another gear in between called an idling gear. What it is? A gear placed in between 2 gears to transfer motion without change of direction. Now, if a couple of moment m1 is applied to the upper one, what is the moment m2 of the couple that must be applied to the lower gear, that is this one, to maintain the equilibrium, right? Only 3 minutes to left before I finish this video in 4K. So D1 is 150 mm and D2 is equal to 200 mm. I have redrawn the diagram for you once again here. This one is same thing as this one is same thing as this, and the idling gear in between is same thing as this. The idling gear is in contact with the first one at this point. The idling gear is in contact with the second one at this point. So supposing this is rotating clockwise. So at this junction, there will be a force of contact, a tangential force P to this side, and here it will be a tangential force M, force P to this side. So P is the tangential force between the interface of the first and the idling gear, and the second and the idling gear, P and P. Now let me apply the turning effect of a couple for the gear 1. For the gear 1, moment of the couple. Look, here is a force P, here is a force P, and the perpendicular distance, that is D1 for this gear, which is given as 150 mm. So the moment will be, the moment of the couple will be M1, will be P times the perpendicular distance. So P times this perpendicular distance, which is equal to, let it be D1, as it is given here. Then since this P is common to both, and P, this is also P, applied force P, this is also P, and the perpendicular distance between them from the line of action of this P and this P, the perpendicular distance is nothing but the pitch of the pitch length of this gear, that is equal to 200 mm. So for the second one, that is the gear 2, the moment of the couple will be M2, so it will be P times the perpendicular distance D2. Equation 1, equation 2, divide this with this or this with this, no problem. So I divide M2 by M1, so I get PP cancels, so I get D2 over D1. So by cross multiplying, you get M2 is equal to D2 over D1 times M1. And since D2 is known, D1 is known, I put the values. So but this comes 1.33 times M1, that is anti-clockwise. So I think it is clear to you. Most of you are watching my channel, but unfortunately most of you have not subscribed. If you feel the explanations are convenient, please feel free. Thank you.